We are told that the problem in this section of problems 1 through 18, that these functions that they're giving us are all one-to-one. So we know that a one-to-one function implies that f inverse exists. So we know that the inverse for this function exists. Let's find it. And we'll start like this. For convenience, we're going to replace f of x with y. So I'm going to write y equals 3x minus 1. Then, because I want the inverse, I'm going to interchange x and y. Now, that might make sense because if I have an x and it goes over to y, then I want to take that y and turn it back into an x. So I'm just going to replace or interchange x and y in this equation right here. So let's do that. Let's get rid of that. So we will have x equals 3y minus 1. And now I'm going to solve for y. So first of all, let's just add 1, right? We're going to add 1. So I'm going to get x plus 1 equals 3y. I'm going to divide by 3. Now there's two ways I can write this here. One way is just to divide the whole side by 3. So if I do that, I'll get y equal x plus 1 all over 3. Now that's fine. Or I could divide each individual term by 3. And I'll get y equals, now, if you divide this by 3, right, there's a 1 out there. So I'll divide it by 3. I'll get 1/3 plus, and then divide this 1 by 3. I'll get 1/3. Now both of these work. What I'm going to do now is, I like this one a little bit better because look what we did. We started out with the form y equals mx plus b. So I know this is a straight line crossing the y-axis at -1 with slope 3. And if I write the inverse like this, I know it's a straight line because it's linear. It crosses the y-axis at 1/3 with slope 1/3. But what I'm going to do now is I'm going to replace y with f of x. And now if we've got this right, what's supposed to happen is this. If you start up here at this corner here, you put a number in. Actually, let's draw this. Make sure we get an idea of what's going on here. So you put a number in, that's a number that's in the domain. So maybe you put a number in like 4. And then what you do is you process 4 using f, which is 3x minus 1. So where does that actually get you? What do you get if you put in a 4? 12 minus 1 is 11. That gets you over here to 11. And then, if we've got this inverse right, if you put the 11 into the inverse, which is what? 1/3 x plus 1/3, that should get us back to the 4. Let's test it out. So I'm going to start here with a 4. I'm going to process it with f, and then I'm going to process that with f inverse. So f inverse of 4. Now we just did that one, right? That's 3 times 4 minus 1. So this is f inverse of 11. Now put the 11 back into the inverse. Now I've got the inverse down here at the bottom. So I'm going to put it right here. So this becomes 1/3 of 11 plus 1/3. Now 1/3 of 11 is just 11/3 plus 1/3. Well, 11/3 and 1/3. That's 12/3, which is 4. All right, so it works. So apparently we have the function itself and the proper inverse. So f of x is 3x plus 1, and its inverse, or as I like to call it sometimes, the undo function, is this one, f inverse of x, which is 1/3 x plus 1/3. So these functions undo the effect of each other. So you start with some number, process it with f, and then unprocess it, undo that processing with f inverse.